So if you were to walk down a busy city street right now and you were wearing this shirt covered in really loud clashing neon geometric shapes.
You'd probably think you were doing a terrible job at camouflage.
Right. I mean, you would assume you were sticking out like a sore thumb.
Yeah, absolutely.
But according to this really fascinating stack of sources we have today, which ranges from encyclopedias like Wikipedia and Camopedia to international tech news from technoid.gr and Digital Connect News.
Not to mention the German cybersecurity reports and designer portfolios.
Exactly. According to all of this, that chaotic neon shirt is actually how you become completely invisible. Welcome to another deep dive, by the way. I'm so excited to get into this one.
It's a great topic, and that neon shirt idea sounds like a total contradiction at first.
It really does.
But it makes perfect sense once you realize that the whole definition of camouflage has basically been turned upside down.
Because the audience has changed.
Right. For centuries, the whole trick relied on this biological hack. You were trying to blend into a background so well that the human visual cortex just kind of skipped right over you.
But we aren't really trying to hide from human optic nerves anymore, are we?
No, not at all. The watchers today are neural networks.
Which perfectly sets up our mission for this deep dive. We are tracing the evolution of digital camouflage. Because, when your audience goes from a human security guard with binoculars to an AI surveillance camera, the magic trick has to change completely.
It's a completely different illusion.
It is. But to understand how we trick AI today, we actually need to look at what the term digital camouflage originally meant in the first place.
Yeah, we have to go back to the late 1990s for that.
Okay, so take us back.
Well, and you hear digital camo, you probably think of modern military uniforms, right?
Yeah, like those blocky, pixelated army suits.
Exactly. And our sources point to a Canadian initiative called the Globe the Soldier Project. Back in 1997, Canada introduced something called CAD-PAT.
The Canadian Disruptive Pattern.
Right. And this was a massive paradigm shift. It was the world's first computer-generated digital camouflage pattern used in actual operations.
Because before that, military camouflage was basically just organic shapes, like the old olive drab uniforms.
Or the classic woodland camo. It was just these large, sweeping macro patterns of brown and green.
I always think it looks a bit like a child's finger painting,
Yeah.
Lots of swirls, but very clear borders where the green meets the brown.
Which is actually a fatal flaw if you're looking through optics.
Really? Why is that?
Well, if a sniper or a scout is looking through a 3-power optical sight, a sharp outline is a huge vulnerability.
Oh, because our brains easily recognize the shape.
Yeah, the human brain is essentially an edge detection machine. We're biologically hardwired to look for sharp contrast lines so we can define a shape and separate it from the background.
So those old organic shapes were basically giving the brain exactly what it wanted.
Exactly. So the Canadian military realized they had to attack the edge detection process itself.
And that's where CAD-PAT comes in, replacing those big shapes with micro patterns. It literally looked like a low-res, pixelated 8-bit video game.
It did. But, it wasn't just about looking pixelated. There's real math behind those tiny squares.
It's a concept called dithering, right?
Yes. The algorithms use the pixels to mathematically blur the edges of the color patches.
So when my brain tries to find a sharp line,
The dithering scrambles that processing. It forces your brain to just lose the borders entirely.
Yeah.
It creates this localized blur that your optic nerve eventually just gives up on.
that is wild. And the data shows this biological hack was incredibly effective.
Oh, hugely. The sources note CAD-PAT was optimized for a gate rate of between 30 and 350 meters against those optical sites.
A gate rate, meaning the distance someone could actually be spotted.
Right. And it was so successful it completely replaced the solid olive drab uniforms in Canada.
And it changed global military doctrine, too.
Yeah.
The U.S. Marine Corps saw this data and developed MARPAT in 2001.
Yeah, they actually used the exact same print screens for their early trials to test the dithering effect.
Wow. And you see it in Estonia's ESTDCU pattern, Finland's MO5. The math just keeps evolving.
Even Canada is rolling out a new multi-terrain variant by 2027 to replace the older versions.
So CAD-PAT mastered the human biological hack. It used algorithms to defeat our visual processing in forests and deserts.
But the math changes completely when you step out of a forest and into a city.
Because the threat environment is totally different now. The most surveilled places aren't forests anymore. There are neighborhoods, intersections, public squares.
And the watchers in those squares aren't humans scanning a tree line.
Right, they're machines. automated facial recognition, predictive AI cameras, license plate readers.
So the whole definition of digital camouflage has literally flipped.
It's no longer a digital pattern hiding you from a human. It's a physical pattern hiding you from a machine.
Exactly. And to beat the machine, we really have to look at how computer vision actually works.
Because I think a lot of people just assume an AI camera looks at a street and sees a person the way we do.
Yeah, that's definitely the most common misconception. A computer vision algorithm has no concept of what a human being actually
It's
is.
just math to them.
Right, it relies on feature extraction. The camera takes the video feed and converts it into raw numerical data.
So it's looking at contrast gradients and lines.
Textures, shapes. It runs those values through a convolutional neural network, which assigns these neural weightings to specific geometric shapes.
Oh, I see. So it's searching for the mathematical signature of a shoulder or a head.
Yeah, and if the feature extraction hits a certain confidence threshold, say it calculates an 86% probability that a cluster of pixels is a human.
It draws that little red bounding box around it.
Exactly, and flags it as a person.
Which brings us to Bill Swearingen. He's a cybersecurity researcher who presented a project at DE Focon called NOR Recognition.
And his approach was brilliant. He didn't try to use dithering pixels to blur human outlines.
No, he
That's a great way to put it. But, finding that perfect pattern isn't just about drawing random squiggles on a page.
No, the scale of his methodology is insane. The sources detail that he ran over 31 million automated tests.
Yeah, he built a self-learning algorithm based on reinforcement learning.
Which is basically setting up an automated fight, right?
Exactly. His AI would generate an adversarial pattern and run it against 11 different open-source detection engines.
Which are the same kinds of architectures used by major vendors like Axon, Clearview AI, and Flock Safety.
Right. And if the detection engine spotted the pattern and flagged it as a 90% match, Swearingen's AI failed.
But if it tweaked the geometry and dropped the engine's confidence to, say, 40%.
His AI got a digital reward, and it did this 31 million times.
Just slowly mutating the math until it completely broke the cameras.
And then taking that out of the digital world and into the physical world was the ultimate test.
Which they did. He partnered with the automotive channel Donut Media for a field test.
Yeah, they printed one of his best patterns onto a custom vinyl wrap and completely covered a 2009 Toyota Yaris in it.
And they drove this screaming neon Yaris right past a deployed Flock license plate camera.
And it worked. The camera pipeline was completely blinded. No bounding box, no vehicle registered.
It was a ghost in the machine. But the sources did mention one really fascinating caveat about that test.
The wheels.
Yeah. Swearingen admitted that the spinning wheels of the car were incredibly difficult to hide from the AI.
Which highlights a major vulnerability in this whole concept.
Because flat, rigid surfaces like a car door are one thing.
But once you introduce dynamic physical movement like a rotating wheel, the spatial geometry of the pattern changes in real time.
And the illusion starts to break. So if a spinning wheel is a problem, imagine a human body.
Oh, yeah. We bend, we stretch, we swing our arms.
Our clothes crease and wrinkle. How on earth do you take the static code and put it on a t-shirt?
In the cybersecurity world, they call this the fold problem. And it's been the biggest roadblock for wearable digital camo.
Because earlier experiments failed the second you moved.
Right. An adversarial print might work perfectly if you stand totally still, fabric pulled tight, facing the camera.
But the second you twist your torso, the fabric folds. The geometry breaks.
And the camera instantly recalculates, recognizes the curve of your shoulder, and that red bounding box snaps right back onto you.
So to solve the fold problem, you need a pattern that doesn't rely on just one static viewing angle.
Which brings us to the designer Simon Weckert and his digital camouflage collection.
Yes. He approached the physics of fabric using a generative AI method called TCEGA.
To produce what he calls adv texture, or adversarial texture.
And the mechanism behind TCEGA is just wild. It's almost like a reverse engineering tool for cameras.
Yeah, instead of training an AI to recognize a pattern, it calculates the exact frequency of pixel noise needed to break the camera's spatial mapping.
It generates this continuous pattern that emits high-frequency optical noise.
And the brilliance of adv texture is that it's omnidirectional.
So it doesn't matter how the fabric folds.
Or if the camera is looking down at you from a steep angle on a street lamp. The noise is distributed across the whole pattern.
It's kind of like a visual tongue twister for computer eyes. No matter which way the AI tries to read the shirt, it just gets confused and gives up.
Neural weightings just collapse. And what's cool is these aren't just lab concepts.
Right. The sources highlight the physical specs, His garments are actually manufactured in Latvia.
using a blend of 65% recycled and 35% conventional polyester.
So it's real sustainable textile engineering combined with algorithmic science.
And we can see exactly why this matters in the real world. Just look at Cottbusser Tor in Berlin.
Right. According to the German reports, as of August 2026, Berlin police started piloting advanced AI video analysis there.
So picture that security monitor. The system is panning across the square, processing hundreds of people.
Slapping bounding boxes on them with 95% confidence scores, tracking where they go.
But then someone wearing Weckert's ADV texture shirt walks into the frame.
The system tries to run its feature extraction.
But that high-frequency optical noise hits the sensor. The bounding box starts flickering erratically.
The confidence score drops from 95 to 40 to 12 and then just vanishes.
Exactly. The person is no longer tracked. To the AI, they're just unidentifiable background static.
And Weckert actually positioned this collection as a political statement against that kind of mass scanning. He called his shirts a test image for the public square.
Which is a huge philosophical shift. I mean, historically, surveillance tech and the tools to evade it were strictly for state and military actors.
But this brings algorithmic disruptions straight to the citizen's wardrobe.
It really empowers the individual. If a recycled polyester shirt can dismantle a multi-million-dollar surveillance pipeline, it completely compromises the trust in those systems.
But of course, the authorities and the surveillance companies aren't just giving up because of a t-shirt.
No, it's a protectural arms race.
The sword and shield dynamic. That's what Professor Kwan Hun Young, a cybersecurity expert from the reports, calls it.
And he points out the glaring vulnerability here. The moment these digital cloaks are shown to the public, they become training data.
Right. The surveillance companies can just scrape images of Weckert's shirts or Swearingen's cart wraps.
Feed them right back into their neural networks, adjust the weightings, and the AI learns the trick.
It is literally an algorithmic game of whack-a-mole.
And law enforcement is already moving beyond just visual data.
Oh yeah, they're deploying multimodal surveillance. If they can't trust visual feature extraction, they use thermal imaging.
Tracking body heat signatures, or 3D face scanners that map depth instead of flat pixels.
And the toughest one to beat is gait analysis, right?
Oh, definitely. That relies on tracking the unique biomechanics of how you walk.
The rhythm of your stride, how your arms swing.
And a loud geometric t-shirt does absolutely nothing to hide your kinetic movement.
That is so true. It's fascinating how this tech constantly bleeds between civilian and military use, too.
Yeah, the concept is circled right back to the kinetic battlefield.
The Chosun Daily and other international monitors actually report that this cat-and-mouse game is happening in the Russia-Ukraine conflict right now.
And though the application is a bit more primitive than Weckert's textures, the mechanics are the same.
Right. The reports note that Russian military forces are painting these heavy black and white zebra stripes and swirling patterns on their logistics trucks.
Focusing on the main bodies and the round wheels to visually break up straight contours.
And it's the exact same goal as the DE-Han experiments. They're trying to disrupt the mathematical contour detection of autonomous Ukrainian AI drones.
Break the shape, drop the confidence threshold, survive the sweep.
But as impartial observers, it's wild to see how pervasive algorithmic observation has become everywhere.
And the stakes for citizens in open centers are incredibly high when you look at how this data is being aggregated globally.
Seriously. The sources detail a major shift toward predictive policing models, like in the UK, where programs are analyzing historical judicial data and demographics, including ethnicity, to flag individuals for violent crime risk.
Before it even happens.
Right. And the reports also note that in China, technology is used to classify people who contact political groups as potential political risks based on their communication histories.
So when you combine ubiquitous visual tracking with that kind of predictive categorization, a digital invisibility cloak isn't just a novelty.
It's a highly sought-after utility. Evading that bounding box becomes a technical defense against systems that just automatically categorize you for existing in a public space.
Which brings us to a really massive, slightly dystopian irony in all this.
Oh, you mean with Bill Swearingen?
Yes. The researcher who ran those 31 million tests.
Right, because he knows about the sword and shield dynamic. He knows companies will use his patterns to retrain their cameras.
So his response is to keep his absolute best adversarial geometries completely offline.
He's deliberately holding back his zero-day patterns.
Yeah, he'll release some versions to prove the concept, but the premium code, the math that blinds cameras best, is locked in his vault.
Which is just crazy to think about. To protect ourselves from secret, proprietary AI surveillance
We
algorithms.
have to rely on secret, proprietary anti-AI algorithms.
It feels like the whole open source privacy movement is just slipping away.
It really illustrates the new reality, though. Privacy in the digital age isn't static anymore.
It's active warfare.
It requires continuous software updates. Buying an adversarial shirt isn't a permanent fix. You're just participating in a patch cycle.
Hoping your t-shirt's firmware outpaces the camera's firmware.
Exactly.
Well, we've traced an incredible journey today, from CAD-PAT in 1997, built by the state to hack the human eye in the forest.
To Simon Weckert's ADV texture today, used by the citizen to hack machine eyes in the middle of Berlin.
The evolution of the camouflage itself is amazing, but what it really shows is how the power of observation has shifted.
Visual processing got outsourced to machines, so the countermeasures had to follow.
The audience changed, so the magic trick adapted. But I want to leave you, the listener, with a final thought to mull over, building on that detail about developers hiding their best patterns.
It's a chilling thought.
It really is. Because if the only way to beat the AI retraining cycle is to keep the most effective patterns a closely guarded secret, will we eventually see a black market for premium invisibility? Imagine a future where privacy in public spaces isn't a fundamental right, but a luxury subscription model. A world where only those who can afford to buy the latest, unpatched, top-secret algorithmic clothing get to walk down the street without a bounding box tracking their every move.